Welcome back. In this video, I will be showcasing the operation of both my memory storage systems, as well as providing a download link in the description below for this world and everything within it. You are more than free to use these for whatever projects you may need data storage for, because currently I do not have anything to use these, and I honestly can't really think of anything good for them. So for this, I am using the most current release of the game, the most current snapshot release. And from there, we are going to start out by looking at my block-based storage system, and specifically the RAM. So in the RAM here, I have some information. We will get that information here by looking at that. Within this block, we have the record item, tag, and storage. Within storage, I have 8 objects listed 0 through 7. And each one of those just has some arbitrary information. I have nothing in slot 0 at the moment because we'll be using that for just whatever. So let's go ahead and start out by interacting with this RAM. To do that, we will trigger a RAM swap, and we will set that value to whatever information we want to flip around within this. So let's say we want to take the information that is in slot 1 here and swap it with what information is in slot 6. To do that, we will enter our two values as a 2-digit number. We will set it to 16, which will swap 1 and 6. As you can see here, we swap the information from 1 and 6. Now if we do our data get again, we will see the information that was in 6 is now in 1, and the information that was in 1 is now in 6. Let's go ahead and undo that by running that again, and our information will be back in place. And let's also show that you can just enter one digit and it will swap the information from slot 0 by default and swap it with the number that you entered. So let's say you enter 7, it'll put the information that is in slot 7 here into slot 0. As you can see, we swapped what is in 0 and 7. If we look again, we now have that empty object in 7 and that double in 0. Let's go ahead and flip those back around because we do want an empty slot in 0 for our examples. And as you can see again, we do have that empty object in 0. Let's go ahead and start looking at the actual data storage, reading and writing with the block-based system. So let's do a trigger, and we are going to read data. We are going to read the data in slot 1 here. This is slot 0, this is slot 1, 2, this would be slot 16, this would be slot 24, and so on, all the way up until slot, well, whatever. So let's go ahead and read the information there. We will trigger, and we will read data from slot 1. So read data in 1, and we read this UUID that I have stored in slot 1. Let's go ahead and see where that writes. This right here, once a bit of information is read, it will write to the 0 slot in RAM. So if we do this here, we have that UUID written into the RAM of our storage system. Now with that, let's just take the information that is in slot 5 and let's put it there into the forefront. So we will RAM swap with 5 like so, and we will have that information in 5 now. Now let's go ahead and take the information that is here and let's write it into the memory storage system. Now to do that, all you have to do is trigger and write data, and you don't have to enter any values because it will find the lowest possible memory address and write to it. So as you can see, we found an address at slot 34. As I said, this is 32, so 32, or this is a 33, then we have 32, 33, and then 34 right here. And let's go ahead, and as you can see, we wrote the information that was in slot 0 right here to memory address 34. We can go ahead and read the data that is in slot 34 just by entering that. And as you can see, we read this right here. So that is how you read and write to that system. Now this will continue to find new memory addresses all the way up to memory address 4095, at which point it will overflow and will start writing at slot 0 again. And that is the block-based storage system. Now we can, as I said, you can just keep writing data to this and it will just keep finding new addresses. And that is everything with that one. So now that we've overviewed the complexities and what's not of this system, let's talk about its upsides and downsides. The upside of this is it does find its own memory locations to index and does create pointers for you basically. you do get that output right here. As you can see, we wrote memory address to 43 after we found it, because we did find an address at 43, then we convert that into hexadecimal, and then we write to that memory address. This right here is your pointer to that information that you wrote, and you can go to the information at any time just by reading the data set at 34. And this is, if you look through the code, you can see exactly what has to happen here to trigger that. It's just a set of functions that write this number, or this number right here. It will write it into the decimal. As you can see, we wrote to 34 right here. And then you just run the hexadecimal conversion, which will then put the cardinal position of that here, and then it will place a read or write head to that position and do whatever it needs to do. If you just look through the code, you can see exactly what has to happen for all that. That's pretty much the upside of this system. Big downside is pretty obvious. It does require physical locations, or a physical location within the world. But I feel if you are doing something that requires this much storage and the on-the-fly readability, where you have to know where it's written, as well as just being able to write to any address and then get that address later, is something so specialized, I doubt you will ever have a world that uses this system that will not have room for this system. So now that we've completely looked at everything within the system, let's go ahead and move on to the single block system. Let's go ahead and isolate the block at 000, which is the block that I am using for the storage in the one block system. So let's go ahead and get the information. Let's start out by just clearing my chat. We will do data get this block here at 000, and as you can see, we just have a bunch of numbers. Now this I've looked at before. This is the integer system that just stores integers. Right now it's just a bunch of random numbers that I wrote a generator to just create random numbers and write it to this system. But that's what's in there right now. There are other things you can do with this. So if you do function and you do one rewrite here, you can do a format mem multi, which will format the memory to multi-formatting. So doing that, we can then get the data here, and as you can see, we now have a bunch of different types of information. We have arrays here on the bottom, then we have objects, and then we have strings, and then above that, if we data get block, and then we do record item tag.mem, and then we access, let's say, 0, you can see we have a bunch of doubles. Right now I'm storing doubles in this because doubles are generally a better way to store information, or store numbers. As you can see, starting at 4, we have strings. Then at, I believe, 8, we start with objects. And then, and then from there, we get into our objects, and then we have arrays. We have 16 different array values within this. We have the 4, 8. If we go to 12, we then have our arrays. And then that is the rest of them, because arrays are the last one. Now, to read and write to this system, there is a RAM address built within, because this is a single block system. As you can see, our current data is just an empty integer, or just an empty object. We can go ahead and modify that. Let's go ahead and modify that to, let's just say, let's do a text string, and we will just say hello. So now we have that in RAM. If we go ahead and read that, we have hello in RAM. And if we go ahead and get the block just entirely, as you can see, the RAM is at the end here. And there's so much information in this that it cannot display in chat normally. So let's go ahead and write to this system. To write strings into that particular area, the string addresses are 1024 through 2047. So let's go ahead and write to that. We will trigger, and we will write int to a value of, well, let's just say 1111. And we will write hello to memory address 1111. Since we are giving this its value to write to, it does only do the hexadecimal conversion and then the write command. And that is that for that. And then to read it, all we have to do is change this to read integer right here. And then we can set that to, let's just do 111 again, so you can see that it says hello. We can also do like 1116, and that's just an empty text string. Let's also do just 097, just a random number, and that has 0. Let's do 2222, and that has an object. We can do, let's do 4000, just as a blank number. That's just an object, or an array, and so on. And that is everything to do with that. And every time you do a read, it just takes the information that you copy, or that you request from that memory address, and it will paste it into the RAM, just like I'm doing with the multi-block based system. It just has one RAM address. You can just as easily implement the 8 RAM address system, but I felt that for this, it's suitable just to have the one, because it is all isolated within one block, and you can handle your RAM elsewhere or still within that same block. So now let's talk about the advantages and disadvantages of this system. Disadvantages are you do not know what information is written to or not written to. So you do have to have preset values, or you do have to keep track of what values have been written to separately from the system. Other disadvantages are this is just generally you can accidentally delete all the data in this system a lot easier than you can clear an entire chunk. This one you can just punch this jukebox and then have all of your information gone. It is within the item, and you can just copy it using a few commands, but it still is a risk. But upsides to this system are it is in one block, but in reality is actually within one array or object. So theoretically, you can write all the information into an entity, meaning this storage system can potentially take up no blocks at all. It can only take up or it can be limited down to only one entity. Now, to address that, you just have an entity with a specific UUID that you want to address, and then you can have different UUIDs for different entities. This also allows you to move it around within the world. If, let's say, you know that you're going to hit the data limit for that chunk pretty soon, so you should move it to a new chunk, you can do that fairly easily. And stuff like that. It's a lot more flexible with its positioning than this system here. This system requires it to be in the in chunk 00. You can theoretically move it to other chunks, but you have to teleport the entity after you move it. With the pointer program, you then have to teleport it relative positions to specific areas within the world, and that's a little bit cumbersome. Other things about the system is this one only uses 256 commands every time you request either a read or a write. It does effectively the same exact thing when you read or write from it. All it does is change whether it's writing or reading from RAM. But otherwise, it uses exactly 256 commands, while this system here, the block-based one, can use as little as 24 and as many as 310. So it depends on what you want to do. But both of these systems can be run as many times as you want per game tick. That is, of course, within the limitations of the commands per game tick. But otherwise, you're not limited by the amount of memory commands you can run. Both cannot run, or have to run each memory command separately. You cannot, let's say, write in bulk. You cannot write, like, let's say, 3 different things into 3 memory addresses that are next to each other within a chain. You do have to write each individually and then terminate that read or write session. Because it does take place all within one function, and then there's sub-functions afterwards. So that is just a general thing with this, but otherwise, that is how both of these work. As I said, I currently do not have any use for either of these, so if somebody else manages to find one that is good on you, I could of course do computational work with it, and I am considering it with some projects, but overall, I don't have a use for it. So yeah, thanks for watching, and I will catch y'all next time.